these are three calculators I'll be using for evaluating decimal equivalents for these applications of integration. Let's see, the first one, what I'm going to want to do is set up the definite integral after I sketch it. So I have x squared minus 1, so it begins at negative 1, and then it'll go up 1 over 1, up 1, 2, 3 over 1, up 1 over 1, up 1, 2, 3 over 1. I'm just getting a rough sketch. Well, not really a rough sketch, that one's a pretty good sketch, but an idea of what that curve looks like. And the other one is negative x plus 2, so I'm going to begin at 1, 2. I'm going to go down 1 over 1, down 1 over 1, up 1 over 1, up 1 over 1. From 0 to 1, which is ninths. They just want you to find the integral from 0 to 1. And find that shaded region. So that makes life a little nicer. Wish I'd have realized that sooner. So from x equals 0 to x equals 1 of the top graph minus the bottom graph. Not squaring it or anything, so it seems to me the top graph is the line minus the bottom graph, and that's going to be the curve. Notice I bracketed that up so I can distribute that negative. I'm going to take the integral now, the antiderivative. That's going to give me negative x cubed over 3 minus x squared over 2 plus 3x from 0 to 1. That's going to give me negative something cubed over 3 minus something squared over 2 plus 3 times something minus, notice everything here I'm going to put a 0 in, so I'm not even going to set that up. It's going to be 0 in the back end. And the item that I put in there is going to be 1. So notice I put the 1 in, I put the 1 in, I put the 1 in, and now we put a 0 in each of these, and that would give me 0 in the back. Now I have to do negative 1/3 minus 1/2 plus 3. And we're going to see what that renders us. Let's see here. That's going to be a 6 on the bottom. Negative 1 over 3 minus 1 over 2. 6, negative 2, 3. I believe that's negative 5, 6 plus 3. 18 over 6. That's going to give me 13 over 6. Let's see if we can't get 13 over 6 from the integral. Math 9 from 0 to 1 of negative x plus 2 minus x squared. Notice I could have simplified, but I'm just going to go with the flow. Plus 1, I know enough to do that, distribute the negative. Dx 2.16666. 2.16666. I'm trying to get 13 over 6 in my calculator, so I want to see if I can't trick it. I believe I hit math. So enter. 13 over 6. It matches up. I want to find the area between these two regions. So I have x squared that starts at 0, 0. And that means I'm going to go from 0, 0, up 1 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3, 4, 5 over 1. Up 1 over 1. Up 3 over 1. Up 5 over 1. And 6 minus x. So that's going to begin at 1, 2, 3, 4, 5, 6. I'm going to go down 1 over 1. Down 1 over 1. Notice it lands on a nice spot there. We continue the process up 1 over 1. Up 1 over 1. And notice that's going to land on a nice spot over there. It is bounded. I want to find the area between these two graphs. So I want to find that shaded region. And I believe this is 3. And I believe this is 2. But I'm going to check algebraically real quick by setting them equal to one another. Let me set those equal to one another and see if it equals, get two answers of, negative 3 and positive 2. So x squared equals 6 minus x. X squared plus 6, plus x minus 6 equals 0. Factor that and then implement ZPP. 3 and 2. Positive, and then it's got to be negative, so that's going to give me a negative 3 and a positive 2. So those are my limits of integration from negative 3 to 2 of the top curve minus the bottom curve. And the top curve is going to be the line, 6 minus x, minus the bottom curve, which is the curve. And that's all. I really didn't need that much space. I'm going to spruce it up a little bit. I don't even have to spruce up. I know that's negative x squared. That's negative x. I'm going to go right to the integral. The integral of 6 is 6x. the integral of negative x is negative x squared over 2. And the integral of negative x squared is negative x cubed over 3. Little Leibniz notation from 3 to 2. And I'm going to try to see if I have enough room to fit this in along here to do my arithmetic. So it's going to be 6 times something minus something squared over 2 minus something cubed over 3 minus a big quantity. And again, it's going to be 6 times something minus something squared over 2 minus something cubed over 3. I have to plug in those items. So the first ones are going to be the 2. And the last one's going to be the negative 3. Well, 6 times 2, that renders 12. 2 squared is 4. 4 over 2 is 2. 2 to the third is 8. Minus 8 thirds. Minus, I'm going to bracket this up so I don't make a boo-boo. Negative 18. 9 over 2 minus 9 over 2. 27 over 3. Negative 27 over 3, but a negative negative is positive. 27 over 3 is 9. And now I can do the arithmetic. That's going to give me 10 plus 18. 10 plus 18 would be 28. I'll just write it down. Minus 9. Minus 8 thirds. Plus 9 halves. Let's see what that equals. 28 minus 9, I believe would be 19. I'm going to do the fraction, adding the fraction on the side here. It's going to give me negative 8 over 3 plus 9 over 2. 6 on the bottom, negative 16 there, 27. 27 minus 16 is going to give me 11 over 6 plus 19. Hurting on your arithmetic. Need a common denominator. Or I'm just going to write it as a mixed number. That's going to give me 19 and 11 sixths. Improper fraction, 6 times 19. 54. 11. 6 times 1 is 6 plus 5 is 11. That's 114. Plus 11. That would render 125 over 6. We can only hope. I'm going to go to my fancy Casio now and see if I set up that integral or evaluate that integral properly. So 6 minus x squared from negative 3 to 2, 125 over 6, it lines up. Cross sections. So I'm going to try my best to graph this. So I have x plus 1. So I start at 1 and go up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. I have x squared minus 1. I've already graphed that one before. Up 1 over 1. 1, 2, 3 over 1. That's how it's going to intersect. Up 1 over 1. And I really don't even have to do algebra. I can see they're bounded by on the interval from negative 1 to 2. I can set those equal to one another and factor it if I wanted to. But this is going to be... this one, the general formula is volume equals the integral from a to b of this radius, whatever this distance is, squared. Okay, because it's going to be a square coming off of it. So I need to find out what that is, and that's going to be top minus bottom. So that radius is the top, which is x plus 1, minus the bottom, which is x squared minus 1. And then that's just one side, so I have to multiply by the other side. That would make that whole quantity squared. Let me come up here and do my formal. So it's going to be from negative 1 to 2. And this is going to be x plus 1 minus x squared plus 1. So that would give me negative x squared plus x plus 2, the quantity squared. Let me do this by hand. Nine squared upon it. Negative x squared, x2, negative x squared, x2. This is going to give me positive x to the fourth, minus x cubed, minus 2x squared, minus x cubed, x squared, 2x, negative 2x squared, 2x, plus 4. I'm going to combine my terms now, so that's going to give me an integral from negative 1 to 2 of x to the fourth, minus 2x cubed, negative 4x squared plus x squared minus 3x squared plus 4x plus 4. I'm going to take the antiderivative of that now. To the fifth over 5 minus 2x to the fourth over 4. That'll simplify. Add one to that. That's going to give me minus 3x cubed over 3 plus 4x squared over 2 plus 4x from negative 1 to 2. Let me simplify this. It's going to be x to the fifth over 5 minus x to the fourth over 2 minus x cubed plus 2x squared plus 4x, leaving its notation from negative 1 to 2. This is going to be a whopper. I'm going to do it below. So it's going to give me something to the fifth over 5 minus something to the fourth over 2 minus something cubed plus 2 times something squared plus 4 times something minus something to the fifth over 5 minus something to the fourth over 2 minus something cubed plus, run out of room, 2 times something squared plus 4 times something. Now I have to plug in all these values. That's going to be 2 up front and 1 in the back. Fifth over 5 is 32 over 5 minus 16 over 2, which is 8 minus 8. 4 times 2 is plus 8 minus 1/5 minus 1/2 minus 1 plus 2 plus 4. Given all these. So that's going to be minus 1/5 minus 1/2 again. Minus, that's going to give me plus 1 plus 2 minus 4. Let me work on this arithmetic. 32 over 5 plus 1/5 plus 1/2. 3 minus 4 is minus 1 plus 1. It's going to give me 33 over 5 plus 1.5, which is 3 over 2. This is going to be over 10. 66 plus 15. 1. 81 over 10. Math 9. Integral from negative 1 to 2 of negative x squared plus x plus 2 squared. Just realized I have to go back and put another parenthesis there. No biggie. With respect to the x-axis, 8.1, 81 over 10.